Hello guys, this is the Empinated and welcome back to this tutorial. In this part, we will design a random entrance spawner for a room in order to have access to the inside. Last time, we finished the general structure with the height of the walls controlled by grid Z, and we closed the room with a ceiling, so it is time to upgrade it with some entrances as shown. Let's get started. Okay guys, so let's open our almighty room spawner to keep going with our tutorial. So I made the decision to redesign a little bit the system just to work with a little more of order, because yeah, I wanted to alter the relative rotations, separating also the locations. So we're going to work with each one in different functions. So the first thing we need to do is to tear down the function of the wall spawner. In order to get some adjustments, okay? Let's start from the end of the function, okay? So it is similar, very similar, but we're going to do some adjustments here. Okay, the first thing we need to do is to create a map called I don't know, available sites. This will be a map of keys, of vector keys, and integer values in order to save the direction from 0 to 3, to know if it's the front, the back, the right, or the left with each vector, okay? So let's first change this order and delete some things. And let's keep the same logic, okay? In this case, if the current element from the vector offsets is contained in grid position, then we don't want it. It means it isn't available. So if it isn't inside grid positions, then we just need to add it to the available sites, and also the array, the current array index, that will be the direction, okay? Let's delete this. Let's call again available sites and obtain the keys. Let's connect there, and also let's make another for each loop. So let's create another local variable called the current side location, okay? And then let's connect the code previously done. Something like this. Our grid Z and our switch case. Okay. Then we just unify R to make a reroute node. Okay. And then let's duplicate this map in order to create another variable called the wall positions. This will save all the wall positions with its current identifier, its position identifier, to work with them in a bit. Okay, no matter which positions are each vector, we just wanted to the location. Okay, this will be a sum from our relative location and also our current site location. Okay, and for the integer, let's just find it in the map available sites. Okay, and finally let's connect this previous part we made the last video. This way we are saving the vector the vector location of each wall, so no matter how many walls we have, we will saving it in the wall positions map with its direction identifier. Okay, so after each loop we need to create a series of functions. So let's start with the first one. That will be, let's create a wall classifier to obviously classify each wall and save it in a different array. Let's say we have all the back walls, so in this classifier we will save all the back walls in its own array. Like, let's divide the right from the left, from the front, from the back ones. Okay, first of all, let's create our first input. That will be our map. Let's create a vector map of integers. Let's call it the map. This one, let's call the keys. Let's get the keys with I for each loop. Okay, just for aesthetical purposes, let's save each array element in a new local variable called current wall. And also the index in another local variable called current index. And also we need a switch on current index. Okay, let's create our 4 cases from 0 to 3. Oh, it isn't connected here, I'm sorry. It is. And let's find from the map, let's find our our yeah, our direction identifier from the map input. Okay, let's compile. Oh, an error. We have an error here. Just let's the wall positions. Okay, so in order to complete this function, we will need to call another function four times. Okay, so okay, let's create our function that will be called get the first row. Okay, why we want the first row? Because just in the first row of the room we just want there to spawn a door, right? We don't want it to spawn in the second row or the third row. No, now we just wanted to get our entrances spawn like in the height of the floor, so our character can get inside. Okay, to explain this a little bit better, I made a little diagram, so it will be appearing somewhere in the screen as previous tutorials. So let's create our first inputs. First of all, we need our wall index. Let's create another input, an array called side array. Another one called first row array, and finally just a vector, a single vector called the current actor. This will be the current actor location, of course. So the idea, as the diagram I made says, is to so the first row array will save only the arrays from the first row, as obviously the name says, in order to spawn there the entrances. So my logic was the following. If the module between the division of the wall index and the grid Z equals to 0, the position is located in the first row. So let's add it to the vector, compile. Let's get to the wall classifier to finish this function. Okay, let's call it get the first row, and let's create some local variables. Okay, that will be all arrays. Okay, the forward post array. So let's also create more variables, in this case global variables for the rows, the first row walls. And now we just need to create the case with each function. Okay, okay, after we compile and save, let's connect. Oh, sorry, it is already connected. So now let's create the actual random entrance spawner with another function. Let's go random entrance spawner. Let's connect it. So here we just need to create a for loop from 0 to a variable -1. This variable will be an input. Let's call it the entrance number, just to get our for loop correct. We just need to subtract 1 so it can start in 0. Let's get our wall spawner, and let's create another global variable called the same, the entrance number, and let's make it instance editable and expose on spawn. So the idea here is to pick a random direction, and to prevent a repetition, we just need to remove the current possible direction after we got our current random number. Okay, so let's build it. So let's create a local variable called the possible directions. This will be an array of integers, and we'll have only 4 elements. Okay, that will be our index direction, our direction index. Okay, so okay, let's call it, let's get random, then let's save it in a local variable called the random number. Let's connect that. Let's create this switch on int to choose a random vector from each of the first row arrays. Let's create a local variable called the current entrance. This will be a vector, a single vector. Then we need to create another global variable called the entrance indexes, because it will be an array of vectors. Let's call it and say, after we modify the current entrance, let's add it to our entrance indexes, because we have chosen at this point the code has chosen the current entrances of each side. And then, to, like I said before, in order to avoid repetition, let's finally remove the random number from the possible directions array. And finally, let's create another function, our final function, that will be working in the wall spawner. That will be called get rotation by mesh. This one, as the name says, will rotate the mesh depending if it is a tile or an entrance, with different rotations for each one. Okay, so let's cut this. And okay, first of all we need an input, also a map called the input map, just the map. And from here, let's call for the keys, and another for each loop. Let's save in a local variable called the relative location. Let's follow the same logic as the wall spawner where we use the contains operation. Okay, so let's call the contains, but in this case we will call the entrance indexes and a branch. Okay, we just need to create a local variable for a mesh. We'll be using here with the cell spawner. So yeah, let's create a local variable called mesh, and let's change its values depending if this branch is true or false. Okay, I'm sorry. If entrance indexes contains this relative location vector, it means our mesh will be a wall and an entrance. Sorry, an entrance. And if not, it will be our tile. Okay. So let's call again our mesh, and let's get the display name. And let's switch on the string to select only the correct rotation, depending if it is an entrance or just a tile. Okay, let's create two inputs. Our first case will be the SM tile, the other one SM entrance. So from this map, let's find the direction index of the current vector. With the found direction index, let's create a switch node on int with our direction indexes 2 times, one for tile and the other one for entrance. For this we need to create another local variable for our rotation, that will be our relative location. I'm sorry, relative rotation. This will be a rotator. Okay, so make sure to connect each rotation as shown, because this is the only way to get the correct rotations. Okay, and in order to make our room. So finally, let's connect our cell spawner to unify the cases, and let's connect the relative rotation and the relative location. Okay, let's compile. Oh yeah, let's connect this to the wall positions. Yeah, let's test this one. So let's compile again, save. Okay, here, so I made a mistake. Here I made a mistake. I forgot to connect the find result in the switch. So please know that you need to connect the find to the selection. In order to get through a mesh, remember to put the collision complexity in the use complex collision as simple option. So we can pass through only the part that has nothing. So after we made this correction, we just we just need to test this one. Let's create a grid of 4 by 4 by 4, for example, and 4 entrance numbers. Okay, so it will be a number for each side. Okay, let's hit play, and yeah, that's it. It works totally fine. It has a door in each side as intended as well. Now we can finally get to the inside of the room. As you previously saw, now we have an upgraded room generator able to spawn up to 4 walls randomly in each of its sides. Also, you can spawn a room with no entrances at all, leaving the variable in 0. Thank you so much for watching the tutorial. Remember to follow me on X at the Empinated, and leave a like or subscribe if you found this tutorial useful. Bye.